I have a wonderful title which I'm going to As web developers, we spend a lot of our time making sure our applications work properly. We do that through a mixture of UI testing and automated tests. And as good engineers, we want to make sure our applications work in various scenarios, not just basic scenarios. For instance, when a user logs in, when a user starts to check out something, when a user wants to return something, use a voucher code, for example. We also, if your application makes any API calls, you also want to make sure your application works from various different responses from your backend. So my talk today is going to be about why it's important to mock your backend during your tests, and how a piece of open source software that we created longer can help you manage your mocks and compose different scenarios. So this is a rough diagram of how the front end sees some of our software. So if you are an Angular developer in this situation, your user uses Angular, Angular talks to an API, Angular talks to backend, there's a whole bunch of third-party stuff like banks, credit agencies. If someone said to you as an Angular developer, you were supposed to end-to-end test this, this system, I want to show of hands, who would say, obviously this is the E at the end-to-end, and then the other side of it, who would say your other side is testing up to here, A? Hands up who thinks that's what you tested. What about A and B? Test up to here. C, and all the way through to D. And almost all of you did not answer any of these questions. It kind of ruined my thing, but like, so we test up to there as an Angular developer. And end-to-end, what does it mean? We actually don't use end-to-end testing because it's actually pretty useless as a description of what we do. There's a lot of difference of opinion in the community about what end-to-end testing means. And there's open tickets on Protractor right now where people are arguing about this. But what we talk about is testing from a user through our Angular application, and we mock our backends. And we talk about those as acceptance tests. So here, our front-end team, we have about 6,000 plus unit tests, which run in less than 2 minutes. We have 1,000 plus acceptance tests, which load up a browser and do stuff, and they run in less than 10. And we have hundreds of systems sort of level tests, which integrate test that whole application, and they take hours. So we're working on making those 2 minutes. So mocking your backend. Some of you are asking yourselves, why would I mock my backend? I have a very small app, it doesn't do much UX stuff, or I don't make any API calls, there's not much UX interaction. In that which case, it's actually probably alright just to use the basic ng mock tools to make very simple mocks. We'll talk about a little bit about ng mock later on, if you don't know what that is. If you don't want to mock your backend because you actually want to do a whole full stack test, mocking your backend is probably a bad idea. But as you start to scale your application in terms of complexity and in size, it becomes increasingly difficult to have consistent tests. Your tests become flaky and non-deterministic. Now, non-deterministic is a pretty loaded word, and I didn't really know about it. There's a really good blog article about this. This is actually a blog, which you can go read. There's a good link from a guy called Martin Fowler about non-deterministic tests. But basically, if your tests are flaky, your integration tests are flaky, they're basically useless. And they become less than this value if they're flaky. So, next slide. So, some people use real backends during their tests. I found this out recently. I didn't actually think that was a real thing, but lots of people use real backends. And I want you to ask yourself, if you use a real backend during your tests, what happens if your tests fail? Was it your application that failed? Was it the backend that failed? Was the internet connection flaky? Was there a latency issue? What was the problem? You can't tell if your tests failed or what was wrong. So some people solve this problem with a fake backend. They use something like Bank, which is open source. baking library, or the backend guys come to you and go, hey, I've got a whole backend here for you. You can use that to test your application against. But the problem with that is then how do you test non-standard behavior? So your backend is spawned up locally on a little service, you run your tests, but what happens if you want to test something slightly different to the behavior? The backend guys might say, oh, well, you can send a command and tell the backend to put you into sort of a logged in state, but then you can't run two tests in parallel. You can't run a test where a user is logged in and logged out at the same time. So there's a problem with that. So if you mock your backend, the sort of standard approach when you start doing Angular is to use ngmock. So in this example, we've got a simple thing which says when you do a GET request on phones, you're going to return 200 and some data. If you do a GET request on users, returns food, etc. Now, if you start to scale this application, adding more and more of these things into this file is just going to become messy. It's going to become hard to read, it's going to become hard to maintain. If you do start to mock stuff like that, it's really hard to actually, as a developer, experience what your app is like for a real user. If everything's mocked, every API call comes back instantaneously, you're developing and you don't see what a real user can see. For instance, when you make API calls, you need to put loaders when things are going to take a long time. Users are going to build 3G connections, the things are going to take time. You're not going to see that. You fool yourself. So just a sort of summary of those problems we've got. If you use standard standard mock backend, you're sort of stuck with standard responses from backends. You have mocks that are really difficult to read and maintain, and it's hard to test asynchronous interactions in your user experience. So this is where I talk about Angular Multimocks, which is why I'm here. This is our superhero. Angular Multimocks helps you organize your mocks to make them easy to read and maintain. It allows you to create mocks from JSON files. It allows you to create multiple scenarios which you can switch between on the fly. It allows you to add delays to API calls so you can test asynchronous interactions in your app. It allows you to compose mocks that inherit from other mocks so you don't repeat a lot of code. So once again, so you can change scenarios easily, you can compose scenarios out of different mocks. Here's an example of a HTTP mock. So if you do a GET request on customer cart, you're going to get back a 200, and you're going to get back a response. Now, I could create another mock which looks just like this, which is going to return back an error response for customer cart. It's really easy to read. As a JavaScript engineer or a front-end engineer, you can read that fairly easily. It's easy to see, easy to maintain. But the fact that you can add delays to your API calls means that you can have realistic delays on an API call basis or globally. So you can say, I want all my API calls to take a certain amount of time. Or you can turn the delay off completely so your tests run quickly. So sort of coming back to our list of things which we were bad about the normal ways, we've got Angular Multimocks allows you to create multiple scenarios and switch between them easily. It allows you to create easily to maintain JSON files in your mocks, and allows you to test asynchronous interactions. So this bit's going to be interesting because I need to code and hold a mic at the same time. That's alright, I'll see if I can somehow position it. As you can tell, I didn't really prep for this. My lovely assistant Chris here. Okay, so we have a little demo application. It shows you a table with some games. Apparently, doesn't show you at all. Uh-oh. Never do live coding in the demo. Hey, you see that? Right, so a really basic application shows you a table with some some games in there. Don't complain about tables, guys, it's alright. It's a tabular list of information. So this is a really simple Angular app. We have some HTML which uses a model of the game to populate the table. It starts out as an empty array, and we make an HTTP call to get the games. Once the game has come back, we populate the array. This is the standard HTTP backend call. We've got a listed response. We say HTTP backend, when you do get request, return the games. So it's pretty straightforward. So what we're going to do is we're going to install Angular Multimocks on this app. So we're going to do install. Okay, so once we've installed that, we have something that I prepared earlier, which is the grunt file. So Angular Multimocks comes with a grunt task, which you can pull into your grunt file. I've defined one Multimocks grunt task, which says the app name. There's a source directory, which is where all of our different JSON mocks are going to go, and a destination directory, which is where the compiled list of mocks gets output to. This multiple files here is actually for when you start to scale your application. If you have thousands of mocks in one file, your application is going to blow up because you run out of memory. So you can do the true will output one mock per scenario, which you can include in your application. So we're going to start to create some folders. So we're going to make the mock data folder. This is where all the mocks are going to go. And in here, we're going to create a new folder called games, because our resource is called games. If you had users, accounts, applications, different resources, you create an individual directory for each one of these. And here I'm going to create a new mock called somegames.json. So this is going to be our default mock. So when our user loads this up, we're going to see this default mock. So I'm going to quickly grab standard response. We're going to get request 200 instead of customer cart. We're going to do games. And instead of this food response, we're literally going to go and get the response from here. We're going to put it into our JSON. Nice and easy to see what's going on. So now we've got a mock, but that doesn't actually get us where we want. We need to actually create a scenario. So I'm going to create what's called a mock manifest. This is where you compose your scenarios this is where you compose your mocks into scenarios. So we'll create a default mock. And our default mock is just going to have our some games mock in it. So right now we can jump into back to our thing, run our grunt task. It's going to generate a mock file. So if we go back here, we can see Multimocks has generated this file. So there's no point in talking about this file right now. If you want to know more about it, you can talk to me. We're going to include it into our application. So now we can go and ditch all of this code previously in our application, make it a little bit nicer. We're going to change our dependency from ngmock to scenario. I want to take a pause now to talk about, right now we've got development code in our production app. By putting scenario in here, we're going to have to get rid of this somehow. So in our Eronga, we don't actually put development code into our production code. So some people would say put a grunt if statement around this and strip it out in production. What we would do though is we would build our app with production code, and then we would use some sort of bootstrap app to pull our app in with our mocks, compose them, and then run our tests on that. It's a much better way, so you don't have to finagle it to make it work. So now I'm going to actually load up Multimocks into my source code. Thanks. So I've included my Multimocks, and now I'm going to include my the output. This is the generated file that we just created. Thank you. So if we jump back to our application, fingers crossed, it all loads up, everything works fine. So now we've not really done much except make it so that our mocks are actually just way more nicer to read for now. But now that we've got the same code up and running, we can ask ourselves, what does this application look like if there are no games? So, I mean, during testing, it's kind of like, okay, maybe it looks alright, so let's quickly add ourselves a new mark. We'll rename this and we'll call it nogames.mark. And it's simply just going to return an empty list of games. We'll go and create a new scenario. So this scenario is going to be called no games, and it's going to return our no games mark. Now, because these things have the same signature, and by that I mean the same URI, the same method here, if you notice that, because we're selecting no games, it's just going to override the one default. You usually have a lot of things in your default and simple things in your override, so they can inherit from the other ones. So that's quite powerful. So we'll quickly generate our box again. We'll jump to our app. This is still the default scenario. Let's change our scenario to no games, and we can see our application with no games. So we've got two different scenarios here, different states of our applications. But this is also kind of unrealistic in that this is coming back instantaneously. So let's see what it looks like when we actually put some sort of real delay. So for our sum games, let's add in some response delay. And we'll say a second. Now your backend guys are probably like, it's never going to take a second, but for the user, their internet connection might be shit, and so it will take a second. So if we load up our default block now, you can see our loader. So now we've got a much more realistic experience of our application. So as you're developing, if you didn't have a loader there and you just had blank, you go, hang on, I need to do something here. I need to go talk to the UX guys, or I need to load it myself. As your app scales a bit more, you're going to want to spend a bit of time making sure that these objects here are organized. It still works quite well at scale, having all the stuff in directories like this. Some extra features you've got, if you organize your objects into the same sort of resources that you have on your backend, and Multimocks can output HAL standard responses. So here, if I added a users object and I loaded up the games object, there would be a link automatically added in underscore links to my game object. So you can sort of explore your API that way. So it's really handy if you've got HAL-based API. We can jump back here. So, how does it work? So, Multimocks uses ngMock under the hood, which basically it just wraps ngMock, which in effect replaces Angular's HTTP service. It uses Grunt to, as you saw, to compile mocks into different scenarios. So there is a cost to doing mocking. You have to maintain your mocks. Your mocks have to be up to date. You need to be communicative with your API team. If you don't have versioning on your API, you need to make sure that you're in coordination. Otherwise, your code will pass, your test will pass, and then you deploy your code and it will break. That's why it's also important to do integration testing. So at Wonga, we tend to do integration testing on happy paths. So we'll pick certain important journeys to test, but we won't test all the different variations in a full stack integration test because, as we said before, they take time and they can be flaky and therefore kind of costly to a business, especially if you require them to go to production for a release. So we don't release too often occasionally. So there's something else that I wanted to drop in here called the demo approach. It's something that we've just started doing recently in the front end team. I think you guys should try and do it in your companies if you can, which is, as an engineer, you develop your code, you commit it, you do all your normal CI processes, face-to-face code reviews, whatever. Your code's ready to go to production. Before you push, you demo your feature or whatever code you've been running with to someone, with an internal stakeholder who sort of understands the product requirements. They can give you feedback about where you've missed out. So just demoing it almost just even to another developer, rubber ducking almost in a way to someone else helps you find problems in your code. This whole thing is actually a really awesome blog post which I've had help with from lots of my colleagues. It explains some stuff a lot better than I have. So go and have a look. Please help contribute. If you want to use this in your production code, please, well, not in your production code, in your development code. If you want to use this, please help contribute. Ask for features, contribute some pull requests, and contribute some pull requests. And check out our Wonga Tech blog.